All right, welcome everyone to your first post-keynote breakout of VMworld. Thanks for joining us. So we're going to talk about Oracle and the VMware solutions that make running Oracle in your environment better, easier, faster, and more efficient, of course. So I'm Amanda Blevins. I'm a chief technologist in the office of the CTO at VMware. And this is Sudhir, my partner.
Hi, morning, good morning. Sudhir, I'm a staff solution architect. I specialize in Oracle technologies.
All right, so if you've been at VMworld before, you've probably seen this disclaimer slide. We don't promise anything. A lot of what we're going to talk about is available today, but if it isn't, don't hold us to the dates and all that legal stuff. All right, so our agenda is as follows. We have a lot to cover, but we'll go through what a business critical app workload looks like, and specifically Oracle databases and what the VMware SDDC is. And then we'll get into subsections around HA and DR. We'll go into performance capacity management, automation, and then how this ties into the hybrid cloud and how you can leverage that. And so here we'll talk about the support announcement that came out maybe a month ago or so, and then we'll wrap it up. So we have a ton of content, and we hope to get through it with you today.
Kick it off?
Go for it.
All right. So essentially, let's have a look at some of the performance characteristics of business critical applications. So when I use the word BCA or business critical applications, it's essentially the Oracles, the SQLs, the Java, and what have you in the shop today, right? And essentially, all of these applications have some or probably most of these performance characteristics, right? So availability is of utmost importance. Performance is important. You have recoverability, scalability, security. So you guys will be getting most of these slides. So there are some of these slides I'll be skipping over so I can get to the meat of the matter here. Right. Again, the reasons why you want to virtualize business critical applications, for example, Oracle in this case, right? You are able to maximize the resource. vSphere is a platform. Essentially what you do is you take a blanket, you throw it around the hardware resources, so you abstract it. And the reason why you want to do that is you want to make sure that you're able to give hot add CPUs, for example. You're able to hot add memory. You're able to then add VMDKs to a fly to an Oracle database. You're able to scale up and scale out, right? Skip over that one. So when we started off a long time ago, when God created Earth and when man created VMware, right? We started off with the ESXi1 and look where we are today. And I should probably update the slide. It's 128 vCPUs. We extended that to 256. So vSphere 6.7, you can run a virtual machine with 256 vCPUs, right? 6 terabyte of RAM. And at some point of time, I'll talk about the enhancements in 6.5, 6.7 and how you can take advantage of that for your huge, big, Oracle databases. 6.5, some of the new features for business critical application. I will be touching a bit on persistent memory. I'll be touching a bit on para-virtualized RDMA drivers, right? With vNUMA, I don't know if you guys have heard of that, but before 6.5, you used to have this nexus between cores per socket, right? And how the physical NUMA node or the physical NUMA topology is presented all the way to the guest operating system. With 6.5 and onwards, VMware became more and more intelligent. We said, you know what, that's fine. You want to go with a two-way 10 cores per socket, or you want to go with two-way 20 cores per socket, and I know exactly that your vNUMA is completely different than what your physical NUMA is, that's fine. Go ahead and do it. I'll fix it and I'll make sure I present the right NUMA topology to the guest operating system. So that nexus between cores per socket and the virtual NUMA has finally been cut. So you will definitely get, starting 6.5, a optimal NUMA configuration for all your workloads. Again, Oracle is just an example here. Anything to that? Good?
I think that's good. We'll jump to 6.7 now. All
right, 6.7, 1 gig large pages, right? So I'll speak a bit of that as well, right? And the fact that you have per virtual machine 1 NVDIMM controller, 64 NVDIMMs per VM. I'll talk about that in the context of persistent memory and how you can use PMEM, persistent memory, in two ways, the block or byte reducible. All right, so essentially, let's talk about how you can deploy Oracle workloads on VMware SDDC, and there are a couple of steps that definitely I want everybody to go through it. First one, read the documentation. There's a reason why people wrote documentation, right? So we are from the field. These are lessons that we learn from the field. So when we come up with something what's called best practices, right? One stands up and asks me. So I'm not only pre-sales, I'm also post-sales. I'm ex-PSO, which means I'm services. I'm a hands-on guy. I'm a lab rat. When I walk into a customer environment, the guy asks me, right, hey, do you really think I have to inculcate all the best practices? The answer is no, you don't have to, right? Anything will work right out of the gate. So if you set up a virtual machine, you put up an Oracle database, absolutely it'll work. Will it work according to your expectations? Probably not. And what do you have to do for that? Best practices. So that's why read the documentation. And once you deploy this virtualized workload with best practices, then now you're able to accelerate that using things like 1 gig huge pages, NVMe, NVDIMMs, right? You have para-virtualized RDMA drivers, persistent memory, so on and so forth. And then when you're ready to spread your wings and go to the cloud, we have cloud offerings as well. We have the cloud on AWS, and then we'll touch upon that as well. So like I said, you guys will be getting the slides, so I want to skip over this one. Take 30 seconds and have a look at the design methodology, right? So what happens is it starts from the requirement gathering phase. Well, you need to sell the project to a stakeholder because you need some kind of buy-in. You need to understand the environment constraints. That's very critical. Because if you don't do that, what happens is, in my terminology, in my language, it's garbage in, garbage out, right? What's up here is what's going to come here. So you need to understand the current constraints. Once you know that, right, the guy in the middle, the DB workload measurement, that's very important, and I'll tell you why that's very important, right? And once, let's say you measure the workload is basically divided into 4 quadrants. You have CPU, you have memory, you have disk, you have network. Once you know those 4 quadrants, then now you're ready to migrate the database. Now, the database migration can either be a big endian to a little endian, HP, AIX, Solaris to x86, or a little endian to little endian. That could be a physical x86 to a virtual x86. Regardless of whichever way you go, there's a bit of a migration and a nuance in there. So you have to keep that in mind, right? And once you do that, you put in your design considerations for sizing. Well, I need a vSphere cluster for so many hosts. I need HA, I need DRS, I need failover, I need an N+1, an N+2, and so on and so forth. Then you start with support and licensing, Oracle licensing, and I will talk a bit about the support at the end of the conversation, so please hold your questions till the end. Backup and recovery, then you start putting in HA, right? Basically, if you want to run Oracle RAC on vSphere, can we do that? Can we run traditional Oracle RAC? Can we run stretched Oracle RAC across metro distance? Hey, how about disaster recovery? Can I run Oracle Data Guard? How about SRM? How about vSphere replication, right? So all of those factors come into being, and once you are set, it's your regular monitoring and tuning. But if you look at all these steps, is there anything that stands out and say, you need to do something for VMware? You need to do step number 1, 2, and 3, and is that special for VMware? No. Essentially, the design methodology is same, and one virtualizes Oracle on a bare metal as one virtualizes Oracle on vSphere platform. So it's transparent to Oracle workloads. Like I said a couple of minutes ago, right? When you create a virtual machine, when you throw an Oracle database in that, if you look at the alert log for the Oracle database, log file for the Oracle database, there is no line that says, hey, look at me, I'm running on a vSphere virtual machine, right? My version is 6.7. It doesn't say that. It says, wow, I'm an Oracle database, and you know what? I'll do what I'm born to do, right? I'll take and load from the application. Again, I'm going to stress a bit more on the workload characterization. On Thursday, we have a workshop. I'm running a workshop from 10:30 to 2:30. That's where I'm going to go very deep dive into workload characterization. So I will be showing examples of how you are able to move from an AIX to an x86, right? The methodology and so on and so forth. But today I'm going to skip over that, and I'm going to skim on the surface here. So workload characterization is very, very, very important, regardless of whether you're running your Oracle databases on VMware or it's bare metal. I spoke about the approach, right? Essentially, once you do DB workload sizing, and once you determine the virtualization timeline, well, do I have a month? Well, do I have a couple of days? Is it the end of the year, right? Then you have one of the 2 options here. The option on the left is basically the pick and drop. Essentially, what you're doing is you're picking and you're saying, you know what, 12 cores or 12 CPUs on my physical equals 12 on the virtual side. Well, there's a reason to it, right? You do want to do the science project, you do want to do the plan and design, but then you don't have the essence of time to do it, right? You're booted out of a data center in probably a month. You don't have the luxury. So what you do, you just move as is. But remember, when you move as is, whether it's a P2V or whether it's an export or an import, remember, it's garbage in, garbage out, right? Whatever is here comes up here. At some point of time, you do need to go clean things up. You do need to go and make sure that your, the vCPUs or memory or disk or network, what you provide is actually what the database requires, right? So that's the left. On the right-hand side, based on a couple of factors, right? So if it's, let's say, you're moving from AIX or HPX or Solaris, the way that I do it, I look at SpecInt. I look at spec.org, right? I look at the CINT 2006 or what's the other one? The floating point, right? CFP 2006, and I say, okay, you know what? AIX, whether it's hyper-threading, whether it's SMT, symmetric multi-threading, 8 or 16 or 4-way, how much does that equal to on the x86 world? So I know exactly how much that looks like, right? Second, look at the operating system. Look at the SAR, look at performance, right? And then tell me how much is the operating system pushing. And once I do that, the third step is look at the actual database statistics and say how much is the database pushing. So an example that I can give you here is a Russian doll, the matryoshka. So you have a doll within a doll within a doll, right? So the outer doll is the SPECint. The doll within is the SAR, and the innermost doll is the AWR. So you need to look at all these three layers, or the layers of an onion, right? When you cut an onion, you see the different layers. You have to look at the different layers to find out what is the amount of CPU. So how much memory do I actually need? Because remember this, oversubscribing or undersubscribing kills you. Right? Undersubscribing kills your performance. Oversubscribing, well, you know what? ESXi has to do the work to schedule and deschedule the vCPU. So you're taking cycles away from ESXi. So what you need here is a plan and design. So essentially, you have two options here, option on the left and option on the right.
Yeah, so in the latest version of vSphere, we announced some new features, and of course we have 7 coming sometime early next year-ish. And so one is VMware App Defense. And if you haven't heard about this, it might be good to check out while you're here this week. But App Defense looks for the known good. So whatever processes are running on your OS will identify through machine learning and through databases that we maintain in the cloud. And so we'll say all these processes that are running are good. Now, if a developer spins up something that's abnormal, or there's a virus or a Trojan or something, usually we're relying and being reactive to some sort of infiltration. But now with App Defense, we identify it immediately. And if you couple it with something like NSX, well, then you can, microsegment it and be able to triage the issue or to work through the issue. So App Defense is important, and of course, so here was talking about sizing. You don't want to oversize, but with this version, we support a ton of CPUs and 6 terabytes of RAM. So now we're going to jump into the software-defined data center and an overview of that. I'll get to this next slide here. You can go ahead and build that out. I'll build that out. Yep. All right. So, of course, we need physical hardware. Software must run on physical hardware. And the goal is that we want to virtualize compute, virtualize storage, and virtualize network and security. And the layer on top of that is around monitoring, alerting, performance capacity management, log analytics, etc. And then there is the automation platform. And the automation platform in this example is specific to the vSphere NSX vSAN infrastructure, but in VMware's portfolio, this can also extend to native public cloud platforms like native Azure, native AWS, native GCP. And then, of course, we need to make sure that our data is healthy and replicated and secure. So this first section that we'll go through will focus on the compute side of things. So hopefully you've seen a lot of these terms before. VMware HA will bring the workload up on another server in case one host fails. vMotion is the technology we use to make sure that the virtual machine does not lose connectivity and activity while it's being moved to another host. DRS is making sure that the hosts are being used in the best way possible. So, if your virtual machine is too busy, then it will make sure that there are enough resources for that virtual machine by moving other virtual machines for you or moving that VM to the host. And then there's fault tolerance. This is a far less utilized feature, but it does work with Oracle databases and very well, and it has since its release in vSphere 4. So these are the maximums that are out there. Definitely always refer to our maximums guide. It changes with each release. So these are very good to know. Is this something that you want to start with the PMEM talk here?
Yeah, sure.
Yeah.
So if you look at the top of the pyramid, right, you have 2 characteristics. It's volatile, but it's very low latency, correct? And then if you look at the bottom of the pyramid, it's non-volatile, but the latency is high. Now, what if I can take these 4 characteristics, probably the non-volatility aspect and the low latency, and marry that and say, hey, can I have a memory that is non-volatile, right? And that's low latency. Can I do that? That's persistent memory. So essentially a persistent memory, so if you look at any of the offerings from HP or even from Micron, right? And I'm not a PMM expert here, but I'll try to do the best I can, right? Essentially, if you see a DIMM, on the DIMM form factor, you have a capacitor and then you have a flash, right? So what happens is when the power on the server goes off, right? Whatever memory buffers are there in the DIMM, it essentially gets copied on to the flash card, right? The capacitor has enough charge. And when the power comes back on, it just starts copying everything from the flash back to the DIMM. So you were there or you were here where you were when the power went off. So that's the use case for persistent memory. So essentially PMEM, right? It's on the PCIe bus, right? It's on the PCIe slot, and then you can use it either you can either use it as byte addressable or block, right? So when you use it as block, it's essentially your read and write or your P read and P write, right? Whether it's async or synchronous, right? That's basically using SCSI commands. If it's byte addressable, it's load and store, which means it's blazingly fast, right? It bypasses the operating system. So for example, there are two modes you can use it, and I think there's a, probably, yeah. This is exactly how the persistent memory is exposed to a virtual machine. So if you were to open the ESXi server, right, the backplane, and let's say put those PMEM chips in, right, and then reboot it back, what happens is when it comes back up, ESXi by default will format those PMEM. It creates the namespaces on the DIMMs, and then it creates a data store. Now that data store is not visible via the web client, but when you log on to the ESXi server directly using the root password, you can see the data store. Now you have an option, right? You can either use it as a disk, which means block, or byte addressable. So what are the use cases here? The first use case for a block, you know what? The application doesn't have to be aware of it, and I'll give you an example here. Assume that you had a 9i database, right? 9i is deprecated, 9i is dead, long live the king, 18c, 12c, and 19c, and so on and so forth. But let's say your Oracle DBA quit. But you guys need to keep that legacy application alive because you have an application which is very important that's feeding off the 9i database, correct? But now the database is so slow and you don't have the Oracle skills to speed it. How would you do that? But let's say, just again, another assumption that you were able to virtualize it before the DBA quit. All you have to do is move the database in entirety, if you can, if it's small, to the PMEM, or at least the redo log files. The log files of the database, if you're able to move it to PMEM, just by the fact that the log files are on the persistent memory, it speeds up the database. So now you're able to accelerate the performance of a legacy database or a legacy application simply by using PMEM in the block in a block format. So that's example one. Second example, byte addressable, right? The newer operating systems, RHEL 6, RHEL 7, SUSE. What happens is they have a new mode of file system. When you mount a file system, you can give options, right? So there's an option called DAX, direct addressable, which means it bypasses the operating system cache. So remember, anytime you have any file system, Veritas, CFS, VXFS, ZFS, UFS, I don't care, I'll tell you, ext3, ext4, there are two caches. There's a user space and there's a kernel space. There's always a context switch. With the DAX mode, you're able to directly go to the kernel space, copy the buffer, and give it to the application. How cool is that? That's great, right? You're able to now avoid that context switching and your application is fast. So again, block space or block addressable, byte addressable, persistent memory, and this is how you're able to basically consume it, right? And yeah, let me see. So I think this is, it's today, yeah. The session is today, so from 5 to 6, I will be going a little more deep dive into persistent memory and also RDMA. If you guys are interested, please do come. But I'll still talk about the different various use cases that I ran with persistent memory, right? The first one was accelerating the performance of the read log activity. I probably should have asked this question before, right? How many guys are, have an Oracle background? How many guys have an Oracle background? Okay, good. And then, so essentially what happens is every database, whatever the database may be, SQL Server, Oracle, MySQL, right? They'll have some log or the other. They have some log file or the other. They have to write to the log file before they go, right? In the VMware land, you have a virtual machine with the log file, right? Every activity or every event is logged in the log file. Similarly, for an Oracle database, it's the redo log file that is the bottleneck. So if you don't write to the redo log file, stuff doesn't go ahead. Stuff comes to a standstill, stuff comes to a stop. So you need to accelerate that, right? So your performance of an Oracle database is a function of so many parameters. One parameter is the redo log file. So I was able to accelerate that simply by putting the redo log file on the PMEM device, the block addressable. Second, you can also accelerate it using the Oracle Database Smart Flash. Third, there's a potential reduction to Oracle licensing. And one would say, what's Oracle licensing got to do with persistent memory, right? 30 seconds, right? If I'm able to accelerate a virtual machine workload, let's say it had 12 vCPUs, right? I just automatically moved it to PMEM. And now I say, you know what? The same workload I'm able to run using 6 vCPUs or 9 vCPUs, right? I'm able to do that using one virtual machine. And assume I'm able to do that across the board for all the virtual machines, which means I now use less number of vCPUs to run my entire Oracle workload. And if I need less number of vCPUs to run my entire Oracle workload, I need lesser number of cores. And if I need a lesser number of cores, I don't have to pay so much of Oracle licensing, right? Again, disclaimer, there's a big disclaimer here. It all depends upon your workload, right? It all depends upon your workload, the kind of metrics you get, right? Any performance metrics that you get is a function of so many parameters, hardware, software, the kind of tool you gather or the kind of tool you use, right? So again, it may vary from customer to customer, your mileage may vary, but again, this is something when you guys go back, you can try this out, right? And that was a white paper on that one as well. That actually goes very deep dive. All right, so switching gears, talking about para-virtualized RDMA drivers. So how many people know RDMA? Remote Direct Memory Access. All right, so what happens is this, right? Like I said, you have, okay, a virtual machine, a physical server, really, it doesn't make a difference, right? You have an operating system. Again, there are two user spaces, or there are two spaces, the user space and the kernel space. There is a context switch every time you do any kind of read or any kind of write, any kind of buffer copy, any kind of buffer write. With RDMA, it's a zero copy. It's a zero OS copy, which means it knows exactly where the buffer is in the user space. So for example, let's say you have an Oracle client here, a virtual machine, correct? You have an Oracle database here. Both virtual machines or both physical servers have two user spaces, right? The user and the kernel. Now, the client says, hey, I need a block of data. Can you please give me a block of data? It's got to traverse all over the wire, come up here, go up to the user space, right? Go up to the kernel space and tell the kernel space, I need that block. I need that block in the user space. The kernel space says, okay, fine, I'll get you the block, don't worry. It goes, talks to the user space, gets the block, ships it all the way back. You see how many steps are involved here? And I'm pretty much missing probably like 500 steps. And I made it so simple for you, right? In this case, what happened, it says, I need a block. He says, fine, I will give you a block. It goes directly to the kernel space, gets the block and come. The reason, the HCA or the adapter, it has a map or it has some kind of mapping between the adapter and the user space. So when it says, I need that buffer, it says exactly where the buffer is, it gives it to that. So RDMA is very low latency, low CPU utilization, high bandwidth, zero operating system copy. Right? What's the use case here with Oracle? Oracle Rack Interconnect. So how many people have heard of Oracle Rack? Oracle Clusterware, Oracle Rack. Come on guys. Yeah. So essentially here's the thing, right? You have a couple of instances or you have a couple of virtual machine or physical servers. Everybody is sharing the same amount of data, right? The same storage. But then blocks get shipped over the wire. Blocks are getting shipped over the wire, and that wire or the cache fusion traffic is what's called the Oracle Rack Interconnect. Now that guy is the heart and soul of Oracle Rack. You take a scissor, you cut it, that's it. Kaboom. Your Oracle Rack crashes, right? You have a cluster eviction. You have, the whole cluster comes down. So your health or your performance of an Oracle Rack is directly proportional to the performance of the Oracle Rack Interconnect. And that's what the PV RDMA or the RDMA will help you with, right? So going back here. So like I said, you know what? Your context switching, you're able to save your context switching using PV RDMA drivers. PV stands for para-virtualized. Essentially what we did was we came up with these para-virtualized RDMA drivers in the virtual machine, assuming that you will be using some kind of card. Maybe it could be an InfiniBand card. It could be a Rocky card, right? And once you use that and you're connected to a Rocky switch, now you're able to push speeds close to 100 gigabit. 100 gigabit. And then in the session today evening, I'll show you guys. This is not all smoke and mirrors. I was able to push close to 99 gigabits a second, right? Not through Oracle, but I'm going to leave that for the evening today, all right? All right. Again, this is not all smoke and mirrors, right? I don't want to stand up and say, you know what, I did it. I want to prove to you guys that I did it. Look at it. I was able to, in my lab, increase the throughput from, let's say, 230 megabytes a second to 262. Oh, one may stand up here and say, that's too low. 262 is too low. I am able to push a gigabyte. Absolutely. Like I said, this was my test case and I was able to get some marginal performance difference. You guys have real workloads, real customer workloads. When you go back, you will be able to push a lot more than what I was able to push with my dinky little servers in my little lab, right? Again, I was able to increase the throughput, increase the IOPS, increase the interconnect usage. I was able to get transactions per second. I was able to get executes per second. So remember, anytime you talk to an Oracle guy, you talk to an Oracle DB and say, can you tell me if the performance has increased? He'll say, yes, you know what, I'm able to do a lot more work. And work in an Oracle land or work in a SQL land or any RDBMS equals, how many SQLs am I able to execute in a second? How many transactions am I able to process? How much work am I able to do? What's the throughput? What's the IOPS? See, these are the qualifiers for a workload in the database land, right? Again, ESXi, 1 gig huge page. How many people have heard of huge pages? The 2 megabyte, right? So essentially what happens is if you look at Linux, and I'm more so from a Linux land, right? If you look at Linux, the regular kernel page is 4K. It's 4 kilobytes. Right? At some point of time, people, they decided to come and say, you know what, why don't we have these 2 megabyte huge pages? He said, there's a reason why you have 2 MB huge pages. How many people have heard of TLB, translation look aside buffer? Every time. So translation look aside buffer is a little buffer in the memory where you are able to map your physical addresses or your virtual addresses to physical addresses, right? Your virtual address is mapped to a physical address there. If you now need to find out where your buffer is, you would actually have to go to the TLB or the translation look aside buffer, start walking the page. It's what we call a page walk. When you start doing the page walk, when you keep doing it, it takes a long time. And when it takes a long time, that is directly proportional to your performance. Your performance sucks after you, right? And they come back and say, wow, this is so slow. Your memory access is so slow. So to reduce that, what we did was, people, the Linux people, they came up with what's called huge pages, 2 megabyte huge pages. So now your TLB buffer is smaller because the huge page or the size of the page is larger from 4K to 2M. ESXi released 1 gigabyte huge page. Typical question I get from customers, should I or should I not use huge pages for Oracle databases? Absolutely. And you know what? Even if you use or even if you do not use, ESXi does not care. ESXi will still use huge pages to protect guest operating system. So it's always a best practice to use huge pages in the guest operating system regardless of whatever your workload is. If it's SAP, SQL, Big Data, HPC, Oracle, really don't care. Use huge pages in the guest operating system because you're protected by huge pages and ESXi. It's a win-win situation here. Remember, huge pages are not swappable. Huge pages are not swappable, right? That's something that kills you guys. If the memory page gets swapped, well, you have to read it back. Well, that's the, you get dinged on performance. So huge pages are not swappable. Good?
Yep.
Anything with that? Okay. Unfortunately, it's always the Oracle, it's never the VMware thing. Okay. It's always Oracle. Unfortunately, Oracle cannot take advantage of the 1 gig huge page. So this is more of a science project I did just to show you guys that yes, we are ready. Oracle, it's time for you guys to bring your act on. But yes, Oracle cannot use the 2 gigabyte huge pages for the same very reason here, right?
Yeah, so another thing that we've been working on a lot at VMware is supporting machine learning. So at VMware, we do machine learning in basically 3 different pillars is how we look at it. One is helping you run your ML workloads on our vSphere platform and Cloud Foundation. A second is to use machine learning in our products, things like Magna and what VROps is doing and NSX Intelligence and a lot of those new features. And the third pillar at VMware for machine learning is to help us perform better as business. So in these next couple of slides, we'll talk about GPU support in vSphere itself. So we've worked with NVIDIA closely. And GPUs are basically just a much faster, or things like FPGAs are much faster in performing model training through TensorFlow or PyTorch or things like that. So when you have data scientists in your company or data scientists that you will be supporting, they're going to ask for hardware to do machine learning. And of course, it's very expensive because they'll probably be buying a lot of FPGAs or NVIDIA cards or something like that. So of course, we want to be able to virtualize these workloads so you can get the same economies of scale as you always have with workloads before. So we can assign GPUs to virtual machines through various technology. It's something that can be assigned directly through IOPath, et cetera. But then we've also acquired a company earlier this year called Bitfusion. And Bitfusion is very interesting because you do not need to have NVIDIA GPUs in the same host that you're going to be running your machine learning workloads. So your VMs that have TensorFlow or PyTorch or other things, they can talk to GPUs that are in another physical host. What's even more interesting about Bitfusion is absolutely you can configure this when you're creating the virtual machine and creating the configuration file. But Bitfusion also supports connectivity through IP. So once the virtual machine is online, it doesn't even need to be connected to the Bitfusion GPU at that time. You can connect it when it's time to train your model and when it's time to run your model or your inference engine. So that's definitely something to keep in mind so you can keep your costs down and make sure that you have all your GPUs in 1, 2, 3, 4 hosts, and you can serve up farms of servers running machine learning workloads. All right, so now we're going to jump into storage. Who uses vSAN today? Quite a few of you. Thank you. Hopefully it's going well. So for those of you that haven't used vSAN yet, basically it makes running storage and managing enterprise class storage far easier than if you have a traditional storage array. So all those empty drive bays that you have in your servers today, you would populate them ideally with Flash, and then we would create a virtual SAN across the cluster of vSphere hosts to create that storage area network. And it does all the same stuff that enterprise storage does, right? We can encrypt, we can replicate, we can dedupe, and all these features, but it's orders of magnitude less expensive than running, something that might be an external array. So this is very good for pretty much any workload out there. You're not going to be hampered by performance because the performance is very strong. It goes back to when you're sizing your workload and you're understanding what are my characteristics, you want to make sure that the vSAN storage array size is appropriate for your workload. And so this is where hyperconverged infrastructure comes in. So hyperconverged infrastructure basically means that the things that I was talking about before, from compute, storage, network, and security, all those functions are running directly on the same host, the same x86 host, regardless of the vendor that you choose. So you're no longer doing storage functions in an array outside. You're no longer doing network and security functions and network gear and security gear outside. You're able to use software to virtualize all of that, just like you virtualize compute, and run that in a single set of hosts. And then it also means that you have a single point of management. Therefore, you don't need to manage your servers in this way, and your storage array this way, and your network gear, and your security gear, and all these different interfaces. Through hyperconverged, you have a single point of management. And when we talk about Cloud Foundation a bit, we can get even to more benefits of that. So when it comes to Oracle and VMware hyperconverged infrastructure, here's our history. But why don't you talk a bit about Metro
Sure.
Cluster and Global DR with vSAN?
Right. So essentially, when we started off with the solution architecture, what we did was the first use case that I picked. I said, you know what? Let me start with the Oracle RAC use case. Because that's typically what the Oracle customers say. You know what? Have you virtualized RAC? Does RAC work on vSAN, right? The reason is RAC is very latency sensitive, right? So if I'm able to tackle that beast, the beast which is very latency sensitive, which is very sensitive to the point that if there's any glitch in the wire, you have a cache eviction, you have a cluster eviction, so on and so forth. So we started with that model. We said, okay, vSAN hybrid, let's set up a 2-node Oracle RAC or a 4-node Oracle RAC. Let's see how does that scale. It actually works very well, right? So we were able to set up Oracle RAC on vSAN. The best thing is setting up Oracle RAC on vSAN is the same as setting up Oracle RAC on a classic ESXi connected to a SAN or a NAS, or for the matter, or for the purpose of discussion, setting up RAC on VMware Cloud on AWS. The reason is everything is vSphere. I didn't have to do anything different, right? When we first set up RAC on vSphere, we had a couple of steps to do it. I just took the same amount of steps. I did the same thing on RAC on vSAN. The only subtle difference is on vSphere, right? When you have a shared device, when you have a shared VMDK, you need to use what's called a multi-writer flag, right? Because by default, when you create a virtual machine, you assign a VMDK to the virtual machine. That virtual machine has an exclusive lock, right? Think of it, it has an exclusive lock on the VMDK. That VMDK belongs to this guy, does not belong to anybody else, right? If you now have to de-escalate the lock from an exclusive to a shared, you will have to use what's called a multi-writer flag. When you do that, now you're saying multiple people can read, multiple people can write. ESXi will not manage the consistency or the concurrency. ESXi will not do that. Who is responsible for it? The guest operating system, the clustering software that runs on the guest operating system, that's responsible for the data consistency and the concurrency. Example, Oracle RAC, right? So that's the requirement. Multi-writer flag with eagle 0 thick. On vSAN, the only thing that we have to do is come up with a storage policy and say OSR equal to 100. So OSR equal to 100, OSR stands for Object Space Reservation, equals to 100. And when you do that, it kind of mimics the eagle 0 thick, and now you're able to put the multi-writer flag, and voila, you can run the same Oracle RAC on vSAN. So we are able to do that as well. And then at some point of time, after achieving high availability within a data center, I said, okay, fine, how about across a data center? Can I run a stretch cluster, a vSAN stretch cluster across metro distance? Can I run a rack across that? I was able to do that. But not just functionally, I have to test it, correct? Not just functionally, test it. So what we did was we ran a SLOB. SLOB stands for Silly Little Oracle Benchmark. It's written by Kevin Clausen. He's a great guy, right? So if you go to kevinclausen.net, and I'm not pitching for him shamelessly, but he's a great guy, you would see the benchmark. So I used his tool, and I was able to run a 100% write-intensive, a 100% write-intensive load on the Oracle RAC. And guess what happened? Nothing happened. I didn't get any cluster eviction, the rack did not fail, nothing really happened. I'll tell you, my rack was able to function properly, right? Step 3, I said, fine, I was able to provide HA. Now how about DR? Can I have data guard, right? From this rack cluster to another location, I was able to do that on site C. After giving disaster recovery, how about backup and recovery? Business continuity. I use RMAN to do that. So all of those details can be available on that white paper. Keep in mind, this is on version 11.204 on vSAN hybrid. But seriously, you know what, really, if you look at the Oracle deployments from 11.204, apart from the fact that you have flex clusters, you have PDBs, you have CDBs, multi-tenancy, so on and so forth, the real Oracle core has not changed, right? The fact that you have hybrid and the fact that you have all flash, I understand there's a lot of fundamental differences, but then the way you set up an application is exactly the same. It doesn't really change. So the link is there in the bottom here.
So we're going to skip through to a few more because I know we have just a very little bit amount of time left. Sure. And definitely a lot of content. So do you want to, let's jump into the networking component of things here. So at VMware, we have a robust networking and security portfolio, and we've been making a lot of acquisitions recently to be able to add to this. But our goal is for you to have virtualized network and security in any environment that you need, vSphere-based and not. And so NSX has been our platform for a while for virtualized network and security, and app defense, like I mentioned earlier, is very important as well. But then we've also made acquisitions around Carbon Black. And when you virtualize something, it makes it a lot easier to automate. So this way we have NSX within your data center. We have NSX for public cloud providers, whether they're VMware based or not. And then we purchased VeloCloud last year, so we provide SD-WAN capabilities, and we have the ability to connect out to the hybrid clouds. Network Insight is also very, very powerful, and this is how you can see what your traffic looked like between any application. Because when we talk about hybrid cloud and you want to run your workload somewhere else, you need to still follow the laws of physics, right? You still need to know what that application is doing and what it's speaking to. And vRealize Automation is our platform, whether it's on-prem or in the public cloud, for you to be able to automate blueprint templates to deploy to vSphere and non-vSphere-based platforms. So how many folks have tried out NSX, either in their environments or maybe at our hands-on labs? Yeah, it's definitely a very, very cool technology and can seem a bit complex and intimidating at first. But basically, just like we've taken the compute virtualization and the abstraction from the server hardware, we've done the same thing from network and security hardware. So now instead of creating VLANs and setting up firewall rules, et cetera, on your physical gear, your Cisco, your Juniper, your Arista, your Checkpoint, your Palo Alto, whatever it might be, you would actually configure that within our software. And so that's very important because NSX lives within our kernel. And so that means that all of the rules that you configure, all of the networking decisions that we make, all of the security decisions that we make, the traffic does not need to leave the host, go up to top a rack, end a rack, core switch, hang off a firewall, see if that's an okay rule to go through, come all the way back, and then allow that traffic. No, it happens at the hypervisor. So there is the logical switch, and that's where we make those determinations. So it's a lot easier to manage your environment with virtualized network and security. We can also do very neat things around this when we have the ability to understand what the traffic flows look like. Have you ever tried setting up a network and security rule, a firewall rule, to say this machine on this network, on this subnet, cannot talk to the other machines on the same subnet? If you tried it, you know it's pretty much operationally impossible, right? Because you'd have to have a transparent firewall inline, and those don't really exist anymore. But because we live in the hypervisor, we're able to do that with a single rule. So if you have a bunch of web servers on the same VLAN, on the same subnet, it's just one rule. Don't allow these web servers to talk to the other. And so that means that when things like WannaCry and NotPetya and that kind of stuff happens, you don't have to be prepared for those specific Trojans. You don't have to be prepared for those specific hacks. You've already protected against it because of that zero trust approach. So we want to make sure that you can micro-segment your applications and say, instead of just having firewall rules between the web layer and the app layer and the app layer and the database layer, now when you automate your deployments, when you deploy your web server, your app server, your database servers, when they're load balanced, when they're clustered, That is your automation point, not just an empty Windows VM or an empty Linux VM. It's the entire application, and it includes your network and security rules. And because these network and security rules are no longer tied to ports or to IP addresses, they can be tied to users that are logging in. They can be tied to VM tags. They can be tied to data center locations, things like that. Because they are vSphere constructs, when you move these workloads to another environment, whether it's another one of your data centers or it's somebody else's data center, or it's VMware Cloud and AWS or IBM or CenturyLink, or whoever you choose, these rules move with it. Because again, they are specific to the workload that was deployed. So when I talked about Log Insight, one, it's a great troubleshooting tool. I was working with a customer, and they told me that they use, and I think of, I'm sorry, not Log Insight, Network Insight. So when I think of Network Insight, it's a great troubleshooting tool for networks. So I think about, this application is talking out to this application in AWS, or this application is talking within the data center. And, our applications are 20, 30 years old. We don't have the documentation. We don't know how they interact, right? But I had one customer share with me that they actually went through a troubleshooting exercise and found that the backplane of their IBM host was having issues when they used Network Insight, because they were able to see that traffic slow down because of a hardware issue, in addition to what's happening on my network and congestion from there. So it's definitely a very powerful tool to add to your environment. And this is, again, very good for planning, and it's also very good for troubleshooting. Planning for microsegmentation and planning for application migration. And then with NSX, because we are able to sit at that hypervisor layer, one, we provide you the ability to NAT these IP addresses. So if you're going to run workloads in one site and another, and we'll talk about this in the DR section, you no longer have to change IP addresses because we're able to NAT that, and that is a huge win when it comes to DR. But in addition to that, Oracle RAC also supports using NSX across sites.
Absolutely. One of the quick point on that one. So two key requirements of an Oracle RAC is shared storage and shared networking. Right. So you require shared storage. You require layer 2 multicasting. Right. With NSX, you have the same subnet across both the sites. Right. So you don't have to come up with some kind of auto magic to actually make it happen. That's why you're able to run extended Oracle RAC across metro distance, whether it's Oracle on VMSC or whether it's Oracle on vSAN, or even whether it's Oracle on stretch clusters for VMware Cloud on AWS. NSX does the real magic. So for an Oracle guy, and I'm not a networking expert, all I just do is, you have NSX, good. I have subnet across both the sites. I'm good from my side. I'm able to run an Oracle RAC across multiple sites. I'm able to do that.
And the important part about extending an NSX subnet across multiple sites is you don't have to extend layer 2 to accomplish that. We can also do that over layer 3. So jumping into the disaster recovery and high availability section, one, Oracle RAC, of course, runs on vSphere. You want to talk about that a little bit?
Yeah. So RAC runs on vSphere. The typical question I get from customers is, why RAC on vSphere? Why? Why should we run RAC on vSphere? The way I explain it is, it's RAC on RAC, right? It's RAC on RAC. It's HA on HA. It's high availability and high availability. What RAC gives you is app level HA, application level HA. What vSphere gives you is infra level HA, infrastructure level HA. And what an extended distance cluster, for example, could be a vSAN stretch cluster, could be a stretch clusters for VMware Cloud on AWS, gives you is site level HA. So you have app level HA along with infrastructure level HA on site level HA. You have 3 levels of high availability. So with any of the cloud, the propositions that we have today, if you're running it in an extended mode or a stretch cluster mode, you are able to get 3 levels of HA, right? The node that you guys need to keep in mind, probably it's etched in my memory forever till the day I die, is 249.212.1, right? And when I come to the Oracle support and the licensing section, I'll talk about that, but that node has been updated. That essentially says, starting November 8, 2010, Oracle RAC is supported on VMware. So if anybody were to ask you in your sleep, is Oracle RAC supported on VMware? Absolutely, it works. And it's supported starting November 8, 2010. This support statement is part of the Metalink, which is mysupport@oracle.com. It's not a VMware maintained site. It's an Oracle maintained site. So it's that's the Oracle guys telling you guys that yes, RAC is supported since November 8, 2010. Right? It's more. So I already spoke about the Oracle Rack disk layout. Keep one thing in mind, if we have to use shared VMDKs for an Oracle Rack cluster, or for that matter, any clustering software, you have to do that using the multi-writer flag. Requisite for multi-writer flag is eager 0 thick, which means you have to do eager 0 thick. A good news for customers, I know how many customers are running VMware Cloud on AWS? All right, maybe I'll hold that for later, but let's move on, yeah.
Maybe after this week, right?
Maybe after this week. All right, extended distance clusters. So this essentially goes into the use cases for extended distance cluster. So keep one thing in mind. Basically, you're able to do site maintenance. It's workload mobility. It's the ability to move workload from one side to the other side while one side goes down. And load balancing. So what you're able to do within a traditional data center is what you can do across 2 data centers when one deploys an Oracle rack across metro distance. This is again, so typically you have one of the 2 options, right? You can either do a host-based storage virtualization, or if you want to do a vendor-based, essentially, which means if you have Hitachi, or if you have IBM, or if you have EMC, or NetApp, right? So they have this metro cluster. EMC has vPlex, right? Hitachi has something else. And then you have HP with pure persistence. You have NetApp with metro clusters. You are able to use all those stretch cluster, right? Topology or stretch cluster architecture, and on top of that, you are able to run Oracle Rack on vSphere. So the couple of slides are basically talk about the vSphere metro storage cluster. For sake of time, we'll probably skip around. But there's something I want to go back, please. There's one thing I want to talk about, and that's this. See the last line that says up to 50 kilometers is stable. Remember, it's the law of physics. It's the speed of light, right? So up to 50 kilometers is stable. Beyond a 50 kilometers, that's really a stretching it, you know. It's not a stretch cluster. You're actually stretching it. You never know what the latency is going to be. So we say, if the distance between 2 sites is 50 kilometers, absolutely, you are able to sustain an Oracle rack. The reason being, and this is not actually set in stone, the rack latency 5 milliseconds. That's what Oracle recommends. Saying, you know what, if you have to have a rack latency on the interconnect, keep it to less than or equal to 5 milliseconds. So if you're running any metro storage cluster, be whatever the metro storage cluster may be, whether it's from Hitachi, HP, NetApp, EMC, or even if it's on vSAN, right? Make sure that the RTT, round trip time for an Oracle rack interconnect is 5 milliseconds. Because beyond that, if stuff happens, Oracle rack support or Oracle support is going to tell you, I told you so. You know, it's got to be less than 5 milliseconds. So that's the thing here. Yeah. Probably can skip this. I spoke about these. Yeah.
So we'll get into Site Recovery Manager. Who's heard of Site Recovery Manager before? Site Recovery Manager has existed at VMware longer than I have. I've been at VMware almost 10 years. And so when I joined, we had like 5 products, one of which was SRM. And if you've ever tried to build a disaster recovery plan without it, you know how painful it is, because you have to you have to use disaster recovery technology and HA technology specific to the OS and to the application that you're working with. So when you have hundreds or thousands of applications in your environment, attempting to do that is virtually and physically impossible. So with Site Recovery Manager, we give you the ability to replicate your virtual machines to another site. We will maintain that for you because Site Recovery Manager is an orchestration engine. So you can either use built-in vSphere replication, so you can replicate between vSAN and vSAN, or vSAN and other storage vendor, or other storage vendor and other storage vendor, whatever it might look like. Or if you have array-based replication from your NetApp or EMC, that is also an option. But basically, you set up a protected site and say, these are the virtual machines and the applications that I want to make sure are available to me in case of a disaster. Or maybe you're just migrating data centers, and maybe you want to have that plan for you. And then you set up your recovery groups, and this is the order in which the virtual machines and applications will come online. So of course, the database server is going to come up before the app server and before the web server, and you'll be able to have all these dependencies. You can even say, I just want to have Amanda do something manually, so let's put a pause in there so Amanda can type something in or throw a switch somewhere or whatever it might be, or call her boss and say, hey, it's all going well. So Site Recovery Manager is a very powerful orchestration engine, and it's very, very good for testing DR. So you can bring up all your workloads on your recovery site, and talking about NSX, we don't have to change those IP addresses, but also we can NAT that off from the world. So now your application folks can test all your workloads. Who has tested DR successfully in the past? Yeah, far less, right? Because it's very, very hard and things change. So this way we can make sure that you can bring up your applications every single day if you want to test. And I have a lot of customers that will run their workloads in one data center for 3 months and run another data center for 3 months and switch back. And so now they are, have a true DR plan that is effective. And so Site Recovery Manager, of course, also works with Oracle. And to be able to accomplish that, we do support scripting like I was talking about before. So we have the examples available to you so you can support Oracle with your Site Recovery Manager instance. So here's just a screenshot of the interface, and you can say, I want to run this command on some sort of separate server on the virtual machine that comes online. And this also means that if you choose not to virtualize your workloads or they haven't been virtualized yet, we can still kick off those failovers and recoveries on those virtual clusters and physical clusters for you. So in addition to Site Recovery Manager, I hinted to fault tolerance earlier. And so fault tolerance is different from HA, different from SRM, different from DRS. And fault tolerance means that we are running a full copy of the virtual machine on another host in that cluster. So every time an operation or write or whatever happens occurs in memory or in the CPU, it also happens on the virtual machine on the other host. And this is something that we've tested extensively with Oracle databases, and it also performs very, very well. So for your workloads that you can't even wait the 5 minutes or 2 minutes or whatever it takes to power on a virtual machine on another host when a host dies, then definitely think about using FT to be able to protect it.
And we increase it to what, like 8 vCPUs?
Yeah, absolutely. Yeah. So if we jump into performance capacity management, hopefully a lot of you are familiar with vRealize operations. It's gone through a lot of iterations over the years. Here's a screenshot for you to remind you. But basically, we want to make sure that your performance is solid, that we can help you do capacity planning, that we have what-if analysis, we can help you troubleshoot, and that also that you are not having configuration drift in some of your security. Now, a lot of people think of VROps or vRealize operations as a monitoring tool. It's not that. It's an analytics engine. So the reason I make the difference and point that out is that originally when we bought the company Integrian, I don't know, 6, 7, 8 years ago, probably 8, it was very clear that the technology behind it was a bunch of calculus, and I don't remember any calculus from high school, so I can't get into the details, but there are 6 different formulas in which we take to try and understand what normal is, and there's a 7th formula that's a tiebreaker. But what we'll do is we'll take in any SQL time series data. So of course we have support for all of our VMware technologies, but then we also work with our partners to take in data from anything else. It could be your hardware vendors, it could be your like Microsoft SCOM, for example, and then we'll also talk about the Oracle specific options. But really we take in this data and again we identify what is normal and we'll let you know what is abnormal. So if you've ever worked operations, and maybe you do today, you're probably pretty familiar with your monitoring tool that will send you an email every time your CPU spikes over 80%. What do you do with that email? Well, you set up a rule in Outlook to route that automatically to trash, right? Because it happens so often. But if you have a tool that's telling you what's abnormal, when this machine always runs above 80%, but then it drops down to 40% CPU utilization, that's weird. That's abnormal. That's something that we want to check into. So the best way to use vRealize operations is to bring in as much data as possible and have this be the platform that will say, when there's an issue, we point out these 3 or 4 areas that might be root cause, and these are the ones that you can jump into, rather than having 20 people on a conference call for 12 hours pointing fingers saying, oh, it's virtualization, oh, it's the network, oh, it's the database. Here we'll give you the exact issues that are happening and identify what abnormal is. So in addition to that, we do capacity management, and we will help you do what-if analysis. So if you need to run or add new applications and new database servers into your environment, you can say, do I have enough hosts for this? Do I have enough CPU? Do I have enough memory? Do I have enough storage? And then we can either model this based off of workloads that you already have, or you can input the values and we will let you know. We'll also help with migration planning if you choose to go to VMware Cloud on AWS or other things. Now, something else we want to point out before we jump into the Oracle specific part is who uses Skyline. So Skyline is something that comes with the support that you already have from us. So Skyline is our proactive appliance that you put into your environment. We continue to collect data about your environment. It goes back to our support teams proactively, and we will notify you, like, hey, this isn't configured properly. Oh, this is an issue. This might be a security concern. You might have an outage because your driver's old, whatever it might be. So we're getting a lot of great data. And when I mentioned before that vRealize Operations and Analytics Engine, well, the way that you can consume that data as well as us is to bring that data into vRealize Operations. So when it comes specifically to Oracle, maybe you can tell us a story as to how you've used VROps for this.
Yeah, so essentially, if you look at any triaging, right, any kind of troubleshooting, the first thing if VMware PSO were to go into your customer, into your workshop, the first thing they'll ask you is, do you guys have VROps? Right, and if the answer is yes, can you please set up VROps? And then the best part of VROps is, there's a company called Blue Medora, and the Blue Medora, they make these packs, right, the management packs. Essentially what happens is, and this is the way I'm going to explain it, right? What vCenter is to VMware is what Oracle Enterprise Manager is to Oracle, right? So when you log on to the console, the vCenter, right, and you click on it, you have the host, the virtual machine view, you have the data stores, you have the networking view, correct? Similarly, when you log on to the Oracle Enterprise Manager, you have so many clusters. They can show you the Oracle RAC cluster. They can show you Oracle databases. Essentially, an OEM somewhat correlate to a vCenter, right? So the best part is Blue Medora makes these packs for both the Oracle Enterprise Manager, which is like a mothership to which all these little satellite databases are connected, or it also makes packs for the satellite databases or the standalone databases as well, right? Now, why am I talking about that? See, essentially, here's the thing. When you look at VROps, right, the regular metrics that you get from VROps, right, that's good enough for probably 70% of all the triaging. But when you actually have to get into the application, it falls short. So the reason is, right, for example, active pages, or when you say, well, what's my active memory? It'll say, oh, my active memory is 1 gigabyte. You know why? Because active memory is essentially the memory that it has touched for the last couple of seconds or microseconds. But that's not how much Oracle is using. Oracle is using 16 gigabyte. Then the guy might come back and say, hey, you said you wanted 32 gigabyte, but look at the active memory, it's 1 gigabyte. Now you need to shrink from 32 gigabyte to a gigabyte. That's completely wrong, right? So now you need an application aware reporting or a mechanism of reporting, right? And that's where the Blue Medora packs, they come into being. So when you deploy that pack, now you're able to extract metrics from the Oracle layer as well, or for the matter SQL Server, or for the matter SAP, or for the matter HANA, or for the matter any other hardware layer or the packs that they have. Throw it on a dashboard, and now you guys have this 72-inch or the 90-inch big TV. Now you can start looking at it. Oh, look at it. The Oracle stats. Oh, look at the virtual machine stats. Look at the storage stats. Look at the ESXi stats, right? Look at everything. That gives you a holistic view. This is essentially what PSO does. I was part of PSO for 3 years, right? So when I has to go in, this is exactly what I has to do. Do you have this pack with you? They say, yes. Can I have a look at it? And then that will give me a very good idea as to what the problem is. And based on that, then the regular Oracle tools comes in handy, right? The way that you monitor the Oracle, the way that you troubleshoot Oracle, you will have to fall back on that. But this is absolutely a very great tool. Again, this is not a pitch for you guys to buy it, but please do evaluate it when you go back. It brings a lot of value to your databases, right? Whether that's Oracle or whether that's SQL Server or MySQL or Postgres or so on and so forth. Yeah. A little more example into what it does. So a DBS can basically go and pick things that they want to pick. For example, DB file sequential read that tells you that's a wait event in Oracle, right? Or scattered read, or my log file wait, or my log file sync, or parallel read, parallel write. So DBS can get the events or the metrics that they want from the Oracle database and throw it on the dashboard. So you VMware guys, along with your Oracle data DBAs, can both look at the dashboard and say, I think, you know what, yesterday morning, this is what happened, the job ran, and this is what the problem is. Let's go fix it. So for triaging, for troubleshooting, for what-if scenarios, an excellent tool.
So when I used to work tech support, or I used to support infrastructure, somebody would call me and say, hey, Amanda, this is broken, fix it. And so my question back to them would be, what did you do right before you called me? Because whatever they just did probably broke what I'm supposed to be fixing, right? So vRealize Log Insight is the technology that we use to be able to do analytics on log files. And this could be log files from VMware technologies, it could be from operating systems, it could be from applications, it could be events. Whatever you might want it to be, we have created packs for this so you can manage different technologies. Now it also integrates back into vRealize Operations, back to that point of what did you just do right before you called me to make this break, right? So in vRealize Operations, when you're trying to figure out Why is my database slower? Why is it unavailable? What's happening? When we have those log events correlated back to the performance events, that makes it very, very powerful. So again, all these solutions are extensible beyond VMware technologies. So the VMware technology capabilities are always built in, but also we want to make sure this is useful for you across your other environments. So you're able to go to our content pack marketplace and download packs, again, for your hardware, for your operating systems, for your applications, and for your databases. So automation. Automation is very important. We won't get into DevOps here. We won't talk about SREs. We won't talk about that. But we will talk about it in the context of making your life easier and making sure that you can do self-service to your users, for your application folks, and for your database folks, so they no longer have to submit tickets and tell you what requirements they need and tell you what needs to be configured, etc. And so you'll see from this very, very busy and confusing diagram that there are so many technologies, as you know, in your environment. And so you have different, Kubernetes distros, you have OpenStack, you have different hypervisors, you have different clouds. You have all of these various platforms in which workloads need to land. And then you have a bunch of technologies that are extensible. You have ServiceNow, maybe for your CMDB. Maybe you have IDS and IPS tools. Maybe you have DNS and IP address assigning and load balancing and all those things on the left. And maybe you already have some scripting that you've done. But the difficulty is that these are done in pockets and these are generally managed by different teams. So through automation, you want to build blueprints and catalog items that take away the manual work from all of these areas as much as possible. And that's also true when it comes to Oracle. So we want to be able to give you that easy GUI, or if you like using text editors, you can absolutely do that too with YAML. But we want to make sure that you can either manage your private cloud or your public cloud, whichever is best for you. And then also we give you the APIs that your developers can use through their DevOps pipelines and to be able to call into ours. So one is IaaS, infrastructure as a service, and then we have PaaS, platform as a service, and then of course we have things like containers and PCF and PaaS and OpenShift. And so here we're going to be focusing more on that PaaS from the example of database as a service through Oracle, but do know that the vRealize automation platform can do all this, and also it can do CI/CD when you build out infrastructure as code. And infrastructure as code is key to be able to automate across your environments, especially as you expand into multiple clouds, because we take an agnostic approach where instead of saying, I'm going to automate this to vSphere, and then I'm going to write the same script, but I'm going to automate it to native Azure, and then I'm going to write the same script, but change it a bit for AWS, etc. If you use GCP, if you use another cloud, all of a sudden you have 4 or 5 scripts that do the exact same thing for the exact same application database server, but you have to maintain it 4 or 5 times. So our approach is that we use our technology to determine what the format looks like when it lands, and you only write it once. So when you want to do automation of databases, it's because people are asking you to use databases. And that's basically why you want to automate, because you don't want them to have to submit tickets and wait 3 days and ask the questions and have the meetings. You have better things to do and they have better things to do, right? So you want to be able to deploy your databases, deploy rack instances by providing them a catalog item where you've done all the work beforehand. So this is an example of the workflow that we've automated in the past to be able to deploy databases for our users. And then this is what you do as maybe you're a cloud admin or a cloud architect or cloud engineer, and this is the beginning of your infrastructure as code. But what the user sees when they want to consume it is just a catalog item. And they could go through the GUI like this, or they could use the API to be able to do the provisioning. But you're able to give them as many or as few options as you wish when they go to deploy their workload. So in this example, we're just having them set up the IP addresses. We're having them set up DNS. We're having them type in a cluster name. We're having them type in a database name. This is all optional. You can choose how much you want to expose or how little you want to expose. So that way, you can also have governance through here. So you could say, oh, you know what? If you want to do 4 CPUs, that's fine. I'll let it go through. But if you choose 8 or you choose 12, there needs to be an approval process from your manager or my manager, whoever it might be. So all of these fields are very customizable. They could be drop down, they can be fill in, they can be pre-populated, they can be not even exposed at all. But the idea is that somebody has a very, very easy experience to deploy databases, whether it's on-prem in vSphere, VMware Cloud and AWS, and Azure, Google, IBM, CenturyLink, etc. All right, so we're going to jump into the private cloud. Who's heard of Cloud Foundation? Pat talked about it a bit this morning, but he didn't get into the details. So I like to think of Cloud Foundation in this way. The last time you upgraded vSphere from planning to production deployment, and maybe you're still doing it, how long did it take? How many months of your life did this take? Probably a lot. The average response that I get when I talk to customers is a year. So we have wasted a year of your life because you had to upgrade our software. Very good software that all your workloads run on, but still, upgrading our software is not important to your business. Your business just wants it to run. Now, say you start using vSAN for virtualized storage and you start using NSX for virtualized network security. If we just use the average of a year, you're spending 3 years of your life just upgrading virtual infrastructure. That is of zero business value to your company. So this is something that we fixed. Cloud Foundation is opinionated engineered design as to how vSphere, NSX, and vSAN fit together. This is something that we configure. We have hundreds of engineers that work on this. We make sure that it's configured not just so it works, but also that the performance is optimal. Because as you start to bring in vSAN and NSX, then things that you might expect to work differently on native vSphere without those components might show some lag time. So we've worked through all of these intricacies, and we give a specific configuration guide and bill of materials to our hardware partners. So you can go to HPE or Dell or Fujitsu or Hitachi or IBM or whoever you wish and say, I want Cloud Foundation. So you say, give me half a rack of servers, give me up to 8 racks of servers. And those arrive to your data center, you plug in network and power, and then you give it basic things like passwords and Active Directory information and network ranges and that sort of thing. You click go. It deploys the entire virtualized stack. It will even call out to lifecycle management of our cloud management platform to deploy the vRealize suite as well. So great, now you can deploy up to 10,000 virtual machines within an hour if you have 8 racks of servers. Okay, so let's go back to the fact that you're spending 3 years of your life upgrading our software. This is a controlled environment. We designed this, we know exactly what it looks like. Because of that, you don't have to go through the standard, download the vSphere bits, test it here, make sure my drivers are okay, make sure my firmware is okay, test it over here, test it there, roll it out, find 7 issues, call support. That's not the path anymore. Instead of downloading vSphere and vSAN and NSX to upgrade, you just download a package from us within the Cloud Foundation interface. And then Cloud Foundation will upgrade the clusters that you say. So you don't have to upgrade the entire environment. Maybe you have virtual machines that are virtual desktops over here running Horizon, so you're going to wait on that. Or maybe you have a development or a test cluster that you do first. But instead of years, now it's minutes. So Cloud Foundation not only gives you this opinionated engineered design, but from an operational standpoint, you're not spending years of your life just upgrading and maintaining our software. It also reduces a lot of the variables in your environment, so you're no longer troubleshooting, oh, well, I have this NAT app over here and it's doing something strange and it's going through this Juniper switch or this Cisco switch or doing something strange. No, we've mitigated all of that because the hardware has been designed specifically for this platform too. So when we talk about VMware Cloud and AWS, this Cloud Foundation that I was just referring to, this is basically the same platform that's running in AWS data centers. We use their hardware, our software, and VMware manages this and makes it available to you as a service. So you don't even need to go into a Cloud Foundation interface and upgrade the software. We take care of that. If there's a host issue, we work with Amazon to take care of that. But you can know that this is the same platform. You still have vSphere, NSX, and vSAN available to you. So whatever you've designed and configured on-prem, if you choose to run your workloads in VMware Cloud and AWS, you can, and you know that it will be the same. We also have engineered direct access to AWS services. So if you are running a workload on-prem and you want to use Amazon S3, well, think of the traffic that has to occur, ingress and egress at AWS. Think of the latency that you have. But if you want to move that workload into AWS without rewriting it and just run it on VMware Cloud and AWS, there's no ingress egress anymore. There's none of that latency because there is that direct connectivity in the back. So maybe you want to talk about this, this reference architecture here.
So essentially, this was an example architecture that we came up with, right? So if you look on the left-hand side, right, you would see a 2-node Oracle rack. That's site A. And then if you look on the right-hand side, that's basically a 2-node Oracle rack on site B. And site B is the disaster recovery for site A. Essentially, it's again in a real application cluster mode, right? Site B is simulated here in the case, and then by layer 2 VPN, by L2 VPN, I have connected site A to VMware Cloud on AWS, and also I have HCX, which is our hybrid cloud extender, from site B to VMware Cloud on AWS. So the best part of L2 VPN, well, I don't have to change IP addresses, right? I don't have to do any kind of platform replatforming. I don't have to change subnet. I don't have to change IP. All I have to do is say right-click, vMotion or enhance vMotion, and off it goes. You're able to send a virtual machine from on-prem to the cloud and back. So you're able to seamlessly migrate, transparently migrate a virtual machine from cloud back to on-prem or vice versa, as long as you have the prerequisite network setup here, right? And then that's basically how you would migrate a standalone database, right? Like they say, the Fisher-Price model, 4-click, right? 4 clicks, you have the compute and storage, resource pool, you pick the networking, you're done. Same when you have to come back, you come back on premises, right? Then at some point of time, right, like I said, right, when you can also deploy Oracle RAC on classic ESXi connected to a SAN or a NAS, or on vSAN, or even on VMware Cloud on AWS, right? So having done that, at some point of time, we decided, can we run extended Oracle RAC across metro distance? So in Amazon world, right, you have what's called AZs, availability zones. That's data centers, right? Data centers separated by metro distance. So that gives you site level high availability. So if you choose to run an extended Oracle RAC on stretch clusters for VMware Cloud on AWS, essentially multiple availability zones, right? Wherein you have these vSAN stretch cluster, you're able to do that as well. Now you have site level mobility, site level availability using this proposition. Keep one thing in mind, it's Oracle RAC, so absolutely you want to make sure you have anti-affinity for your Oracle RAC virtual machines. You don't want everything to land in the same site, right? For high availability. Again, so that's one way of moving it, right? The other way of moving it is what's using a tool called HCX. You are able to either use the cold migration, the replication, or vMotion replication assisted vMotion. I will be talking about that more in detail in this in the session today evening. So if you guys are interested in learning a bit more about HCX and how that translates to or how that relates to, well, let's say SAP or with Oracle, please do come to the session. Probably we don't have time here to talk in today's session. But then I want to take at least 10 minutes and talk about not core licensing, but what the new support statement means, right? So how many guys have heard of the September 16th announcement between Oracle and VMware? Guys have not? Well, that's like a memorable or a momentous day for us, right? Wherein VMware and Oracle said, oh, you know what? Let's bury our hatchets. Let bygones be bygones, right? No more enemies. We're all friends. Let's all sing Kumbaya, right? That's exactly what it was. So September 16th, Oracle and VMware decided to bury the hatchet, more so from the Redwood shows, not so much from Palo Alto. Essentially, we had a strategic alliance, and the alliance was Oracle would then become a VCPP partner, a VMware Cloud Partner Program. They will be part of that, right? So as part of the support program, read the last line, please. It says, customers will have access to every Oracle support, every and all Oracle support for Oracle products on VMware, right? That's one. A month later after that, remember the support link, the 249.212.1? That got updated as part of the new partnership. And what happened was, it essentially said that customers with active support contract can run any and all Oracle products on a VMware virtualized platform. I'll repeat it again. Customers can run any and all Oracle products on a VMware virtualized platform. So it means you can run WebLogic, you can run whatever you have, right? You can run your Fusion, you can run your Hyperion, you can run your RAC, you can run your OBIE, SOA, or whatever you have running in the shop. You can run that on a VMware virtualized environment, as long as you have, of course, an active support contract from both Oracle and from VMware, right? And it has to be a supported version. And as I mentioned before, Oracle RAC is supported since November 8, 2010, right? And if you were to go to the blog articles, essentially, I give you a snapshot of the statement before and a statement after. There's one key thing I should probably should have mentioned here. See, there was a statement in that support statement. There was actually a paragraph in the support statement. Many customers actually know what I'll be talking about. If Oracle has an issue, Oracle reserves the right for customers to replicate the same on another physical platform. You guys remember that? That is gone. So all of those if, but, when, and where, all of the stuff that Oracle had put in, everything is gone. It essentially has only 3 paragraphs. It says first, Oracle supports all Oracle products running on VMware virtualized platform. Second, it says Oracle will do the best to help you guys. Please take help from VMware as well. Third, it says Oracle RAC is supported since November 8, 2010. That's it. It doesn't talk about, hey, you know what, you have an issue, well, you need to replicate it on another physical platform. If you're not able to do that, well, go and talk to VMware. And all of the nonsense that used to be there, that's why we didn't want to have the session recorded, right? All of the nonsense we had, that all of the stuff is gone. So it's a very good proposition. It's a very good proposition from Oracle, right? So there's an Oracle session tomorrow, Wednesday. I think it's either at 1 o'clock or 2 o'clock. They will be talking about the OCVS, the Oracle Cloud VMware Solutions. So if you guys are interested to learn about that, please do go. You have Faisal and then you have Scott Macy from Oracle, and I'll be there as well. That's where they'll be talking about this partnership in a bit more detail, and they'll be talking about the cloud offering from Oracle there. So that's the Oracle Cloud VMware Solution. So we already have the Azure VMware Solution. Now we have the Oracle Cloud VMware Solution that they'll be talking in the session tomorrow. I think it's like 1 o'clock or 2 o'clock, right? But apart from that, let me reiterate. 3 documents, only 3 legal licensing documents that's legally binding on any customer, and I don't care if the customer is an AIX customer, HP UX, or if it's Solaris, or if it's x86. Those are the technical support statement, which essentially says customers will pay 20 to 24% towards Oracle support. Second, the core processing factor, which essentially lays a weight on every processor family. So Intel is 0.5, Solaris is 0.3, IBM is 1, i10M is 1, so on and so forth. But last but not the least, the most important, the Oracle Licensing and Service Agreement, aka the Oracle Master Agreement, which defines processor, socket, cores, the 8-day rule, and the 10-day rule. And it essentially says processors are those processors where Oracle binaries are installed / and are running, which means you only have to pay for the food that you order in the restaurant. You don't have to pay for the entire restaurant. Good. You only have to pay for the mortgage for your house, not for the entire locality, not for the entire neighborhood. So no more Galaxy licensing. That was never an issue, right? See, licensing was never an issue for running Oracle on VMware. The real issue was the garbage and the nonsense around licensing, which says you need to license that alien spaceship that flew past your window yesterday night. Yes, that was a problem. Now, most of the problem is going to die away real soon, right? But apart from that, these are the only 3 documents relevant for any Oracle licensing. There are many Oracle licensing sessions here that I will absolutely recommend you guys go. People, I think Dave Welch, House of Bricks, is presenting one. Then you have other guys presenting there as well, and they'll be more articulate and more descriptive about this entire subject than I can, right, in my 3 or 5 minutes that I have left here. But apart from that, I think we are at the end of the session here.
Yeah,
just quickly wrap it up here.
Yeah, so as a good summary, hopefully we've touched on enough of each of these layers so you know how else to spend your time at VMworld this week. There are a lot of things that we didn't get to touch on because of the portfolio that we have, but each solution at these layers provide value to running your Oracle workloads and other business critical application workloads. If we want to summarize, the top 7 points, we want to make sure you have high performance, that you have high availability, it's secure, you're able to automate your workloads, including your databases, their performance capacity management, cost transparency, and of course supporting hybrid clouds, specifically vSphere-based ones in this conversation. So here we have a bunch of stuff up here. So there's some cards.
So these are not my business cards, and I'm not going to spam you guys, but these are magical cards. The reason is there is a link at the bottom here, right? It's essentially the one-stop shop. So what I've done is there's a link that I maintain, and essentially every Oracle white paper, be that licensing, be that performance tuning, be it Oracle on VMware Cloud on AWS, vSAN, vBall, whatever, right? Whether it's persistent memory, RDMA, everything I collect and I post it out there. There's an RSS feed. If you guys want to learn more about Oracle on VMware, subscribe to it. But again, this is not my business card. I'm going to leave these cards here. Just grab a couple. These are magical cards. So if you guys are doing any kind of POCs, you want to find out about best practices, hey, how do I run Oracle RAC on VMware, right? How do I do this? It's all here, right? I'm going to leave this here. Guys, help yourself to it. But then if you have any questions, please. There's a lady with a mic.
Yeah, so thank you. There's a survey, of course, after every session, and fill that out. We'll take a couple questions even after the session is over. I bet you all are hungry, so they gave us a slide to tell you where lunch is as well.
A couple of Amazon stickers as well, if anybody's
Yeah,
interested.
we got a few VMC and AWS stickers that I took from William Lamb on the way here, so definitely feel free to take those as well. But thank you, everyone, for joining us, and enjoy your VMworld.
Thank you.